Multibase blocks, multiplication and area model.
Hello, little mathematicians. Today we are going to explain multiplication. As we are going to define it, multiplication is a repeated addition. Although we as the students may not realize it, multiplication is taught in second grade since the moment we take a square and split it in rows and columns. In this way, we perfectly understand the idea of multiplication as a repeated addition. As any other arithmetic operation, multiplication has its own properties, and here we are going to learn them. One of them is the commutative property, which means that the order of the factors doesn't vary the product. Let's look at an example of the commutative property. The other property is the associative. The way of grouping the factors doesn't vary the result of the multiplication. Let's see an example of the associative property of multiplication. Another property of multiplication is the distributive property. It means that the multiplication of a number by a sum is equal to the sum of multiplications of that number for each one of the addends. Let's give an example. 2 times 3 plus 5 in brackets. Finally, the last thing that we have to take into account in the multiplication is how to take out common factor. This is the reverse process of the distributive property. If several addends have a common factor, we can transform the sum into product by extracting that factor. Let's take an example of getting a common factor.
Multibase blocks of Dn. The multibase blocks of Dns is a material designed to reproduce the characteristics of any numbering system, trying to formalize the principle of grouping. This material consists of a series of pieces, usually of wood or plastic, that represent units of first, second, third, and fourth order. Units, then hundreds and thousands. Ones are represented in the form of 1 cm side cubes, first order units. The tens, groups of 10, are bars composed of as many cubes as mark the numbering system. The bar consists of 10 cubes attached. Each unit is perfectly separated by a slot in order to give the impression that the units are stacked together, but with the important objective that so units of different order take over themselves and become really and physically a higher order unit. In the decimal number system, they would correspond to the tens, units of second order. Tens bar are 10 centimeters, 1 centimeter, and 1 centimeter. The hundreds, groups of 10, are plates representing the units of third order and consist of a square surface composed on each side by as many cubes as indicates the base of the system of numbering. In our system, the plate would be surface 10 and 10 cubes, each one separated by a slot. The blocks are cubes whose volume is determined by the base of the system. In this case would be 10, 10, and 10 cubes, representing 1000 cubes or 1000 ones, 1000 groups of 10 cubes.
Generally speaking, what it is pretended through all the solved activities made with the materials is that children understand numeration systems, how units of superior order are formed, how the procedure to represent natural numbers, the relative value of numbers, calculation procedures, applying them reasonably and not mechanically, comprehension of mechanisms and algorithms of operations, mental representation of operations, making mental calculation easier, reasonable calculation practice, focusing on classification and sorting concepts, development of invention and attraction to more varied ways of working with mathematics, and the development of mental agility, attention, judgment, and order habits.
Okay, now you understand the multiplication and the multi-base blocks, we can explain what is the area model. First of all, what we need to know in order to work with area model is that we will work with a rectangle of dimensions a times b. In our case, 14 times 27. That means that our rectangle measures 14 ones long and 27 ones high. Although our numbers can be decomposed in ones. As for example, 14 can be decomposed in 10 plus 4, and 27 can be decomposed in 20 plus 7. Knowing this, we can consider the position of our rectangle in 4 parts that represent 10, 4, 20, and 7. So what we have is at the end we have the consequent operations. 10 times 20, that makes 200, as we see in the multi-base blocks with the two groups of 10. 4 times 20, that makes 80 with 8 bars of 10. 10 times 7 with 7 bars of 10, that makes 70. And 4 times 7, what makes 2 bars of 10 and 8 ones, adding 28. Ergo, once we have the results of each multiplication, the total area of our rectangle is the addition of the 4 results: 200, 80, 70, and 28. All this adds up 378. That is the same as 14 times 17, as we can express it in the way of 10 plus 4 times 20 plus 7. That's the key of the distribution property.